Hello guys, today we are going to talk about pre-block that is given in our Ncert class 12. We'll start with group 15, 16, 17. We'll compare the four characteristics mainly: electronic configuration, the atomic and ionic radii, ionization enthalpy, and electronegativity. I'll make it easier by comparing these three groups together, how the series is followed, like how it decreases and increases down the group. So we go to the groups. We'll see first the elements. Group 15 consists of nitrogen, phosphorus, arsenic, antimony, and bismuth. Group 16 consists of oxygen, sulfur, selenium, tellurium, polonium. 17 consists of fluorine, chlorine, bromine, iodine, and astenine. First, we'll talk about electronic configuration. Group 15 has an electronic configuration of Ns2, Np3. Over here, these half p-filled orbital gives an extra stability to these elements in group 15. Now N over here represents their periods, in which period they are placed in, like nitrogen is placed in period 2. That means we'll put over 2, like 2s2 and 2p3 is the valence electronic configuration. Group 16 has a configuration of Ns2, Np4, and group 17 has Ns2, Np5. We'll move up now to ionization enthalpy. Now, what is ionization enthalpy? Ionization enthalpy is the energy that an atom needs to pop out an electron out, like the valence electron. So that much of energy which is needed for an element to pop out one electron is ionization enthalpy. Here we can see that it decreases down the group. Now, what does that? Size increases. It is the main factor which makes it decrease down the group. Size increases in the group and this decreases down the group. So the lower elements need lesser ionization enthalpy to pop out an electron, because this has no command of the outer orbitals when it grows in size. We'll next talk about the radii, the atomic and the ionic radii. Now, this increases down the group. How? Because the shells are getting added. I mean orbits, like 1, 2, 3, and nitrogen has 2, sulfur has 3. As it goes down the group, 1 gets added, and 1 can contain, it's suitable. It's like first has 2 and the second has 8, and it goes on increasing. Lastly, we'll talk about the electron gain enthalpy. Electron gain enthalpy, it decreases down the group. Now, electron gain enthalpy is just the opposite of ionization energy. Ionization energy is the energy you accept. Electron gain enthalpy is the energy required when you release the electron energy to get one electron in the valence electron. That decreases down the group. Electronegativity, it decreases down the group too. When it decreases, that means the metallic character increases down the group. It's just the opposite and vice versa you can think of. Now, when we compare the ionization energy of group 15 and 16, group 15 has comparably more ionization energy because it has a stable configuration of Ns2 and Np3, so half-filled configurations are more stable, as you know. Fluorine, we can just compare these. Now, we can see that N, O, and F. Now, over here, the size in up period it goes down, like the size is greater in nitrogen than in oxygen, and then fluorine is the least small in all these. And then same over here. In each period, N has a greater ionization enthalpy than oxygen. I'm just comparing these two. I'm talking this has more ionization enthalpy than this one in the same period. Now, this is because of the stability, and fluorine has a very, very high ionization enthalpy. Now, because it needs only one electron to move in, and it doesn't want to lose electron, it just wants to gain one electron and be stable like neon, the neighbor. So you understand, I hope this video was helpful to you. Thank you. Please like the video if you just like and enjoyed this video, and I hope it was helpful. Thank you.